All right, guys, here we have our last section of the chapter, section 6.3. I'm going to go through this front page in this video, and then I will save the last 3 problems on the back for in class. But very first thing what we're going to do is we're just solving equations like normal. There is something different that I'm going to have to do to this interval given the fact that I am solving for x over 2 here. So that is the difference. If you look back at the notes packet, all the other problems we've done have been regular x or regular theta here. This is different because it's x over 2. I know we have some double angle formulas that you guys memorized last chapter where this is sometimes like a 2x. That's different in this case because this is x over 2. We haven't done anything like that before, so let me show you what that's going to look like. Keep in mind I'm over the interval 0 to 2 pi, give all solutions. So I'm going to be in radian mode here when I give my answers. But what I'm going to do first is just solve this equation. So I'm going to divide both sides by 2 in order to cancel that 2. So I have sine x over 2 equals 1/2. Okay, so in this case, there are a lot of places where the sine of something equals 1/2. And here's the new part, is that I have never done anything where it's not just a regular theta here. This is x over 2. And so what I have here is, because this is x over 2, what I need to do to my interval here is divide it by 2. So that means my new interval is 0 divided by 2 is 0, but 2 pi divided by 2 is just regular pi. So what I'm looking at now is I am looking at my unit circle where the y value equals 1/2, but I am only looking between 0 and pi. So that means quadrants 1 and 2. And since the sign is positive in both quadrants 1 and 2, I have 2 different answers here. This means that x over 2, it's whatever this is what I'm solving for. It's like if it was a regular theta. In this case, it's not a theta, but it's x over 2, but I'm still looking at the unit circle to figure out where the y value is 1/2. And so that is, it's a 30-degree reference angle, so that means pi over 6. And in quadrant 2, it's 5 pi over 6. Okay, except notice how I haven't solved for x yet. This is x over 2. I just took whatever this was and looked up my unit circle stuff and got pi over 6 and 5 pi over 6, but it is x over 2 here. So in order to get x by itself, what I'm going to do is multiply everything here by 2. So to get regular x, which is solving for the equation, my 2's cancel here. I get 2 pi over 6, which reduces to pi over 3. And I get 5 pi over 6, which reduces to 5 pi over 3. And these are my 2 answers for this problem. And so the problem, or the new part is, and this is kind of the tricky part, is that when you get to this part, when you are looking at the unit circle for something, this is the theta that I'm looking for, but it's not theta, it's x over 2. So I have to do one extra step after I come up with my unit circle answers. But because this is x over 2, I am looking at the unit circle in this divided by 2, which is this interval. And that's how I got this answer and this answer. And I had to divide them, or multiply them by 2 in order to get x by itself, so I got pi over 3 and 5 pi over 3. Let's try another one. This one is very similar, except it's cosine instead of sine. But what I'm going to do first is divide everything by 2, so that's going to give me, oops, let's go black on accident. Cosine x over 2 equals 1/2. And so again, I'm on x over 2 here, so what I have to do here is cut this interval in half. So again, I'm on 0 to pi. And so on 0 to pi, where is the cosine 1/2? I'm only looking on 0 to pi. And the cosine is positive in quadrants 1 and 4, but quadrant 4 is not in this interval. So I'm only going to give the quadrant 1 answer here. And so that means that x over 2, whatever this is, right here, is equal to, where is the x value equal to 1/2? So that's a 60-degree reference angle, which means pi over 3. Keep in mind the other answer for where is the cosine of something equal to 1/2 is 5 pi over 3. So I'm going to make a little note about that. Not also 5 pi over 3, because it's not in interval. So my other answer for cosine does not fit in that interval, so that is why I'm not listing that as one of my answers. And now I have x over 2 here, but I want to get x by itself, so all I'm going to do is multiply both sides by 2. So that gives me x equals 2 pi over 3 is my one and only answer. So let me compare these two questions really quick. They were almost the exact same. One of them was sine and one of them was cosine. Otherwise, they were the exact same problem. But when I have a restricted interval 0 to pi, the sine is 1/2 in both quadrant 1 and quadrant 2. That's why I had two answers, because the sine is positive in both of the quadrants that fall into this interval. In this case, the cosine is positive in only the first quadrant here, and also the fourth quadrant, but the fourth quadrant answer does not fit in this interval, so I can't use that. Okay, let's do a couple more. This one, cosine of 2x equals cosine of x, again on the interval 0 to 2 pi. What I'm going to do is use my identity for cosine of 2x, and I'm going to use the one that has only cosine in it because there's a cosine on this side. A trick or a way to simplify these is to stick with having only one trig function if possible. It's not always possible, but that is why I'm going to use the 2 cosine squared x minus 1 formula instead of the sine formula or the one that has sine and cosine in it. I want to stick to having the same trig function in the whole formula. Now remember, one of our strategies is to bring everything over to one side so that I can have 0 on the other side. That means 2 cosine squared x minus cosine x minus 1. Let's try and factor this thing. I believe I got it factored correctly. Yeah. Okay, so now I'm going to solve my two different equations. This part means that when I get cosine x by itself, I get negative 1/2. And in this case, I have cosine x equals 1. Okay, so let's talk about the interval. In this case, this is regular x. This is also regular x. When I solve these, I am looking on the regular interval 0 to 2 pi. This is not x over 2 or anything different, so I do not have to cut this interval in half. So I'm just going to use this regular interval for this problem. Regular interval for this problem because it's just regular x. It's not x over 2. Okay, so in this case, where is the cosine that x value equal to negative 1/2? Those answers are in quadrant 2 and quadrant 3. That's a 60-degree reference angle. So I'm doing what? 2 pi over 3. And also in quadrant 3, it would be 4 pi over 3. That is where the x value equals negative 1/2. And there is one place on the unit circle where the x value equals positive 1. And that is just 0 radians. So those are my three answers for this problem. So just keep in mind that one did not have a different interval because once I am actually looking up my unit circle stuff at this step, these are regular x's, so I do not have to divide this by 2 like I did in my earlier problems. Okay, let's do this last one. Here we're switching to degrees. Remember, this whole chapter we switch back and forth. I'm not sure why there isn't consistency for the chapter, but just be prepared to switch back and forth. And keep in mind these are thetas also, so technically that's the rule. This I'm recognizing as one of the formulas that we kind of know. So remember how we have this formula that is sine 2 theta equals 2 sine theta cosine theta. That's what I thought of when I saw this formula, but it's not 2 cosine theta sine theta, it's 4. So what that means I'm going to have to do is just multiply both sides by 2 in order to make it match. So now this equals this. So I'm going to write 2 sine 2 theta equals radical 3. So what I did is I replaced this with this because it's equivalent. This is the 2 sine theta cosine theta times 2, and that's my identity for sine 2 theta. Whatever I do to one side, I have to do to the other. So since this is this in the equation, I'm replacing that with 2 sine 2 theta equals radical 3. I'm going to divide both sides by 2. I'm just trying to solve for sine 2 theta. Okay, now, in this case, I'm looking at the unit circle now. I have something weird here for my theta, but I know where there are y values on the unit circle that equal radical 3 over 2. Let's talk about the interval. Because the theta is actually 2 theta, what I have to do is multiply my entire interval here by 2. So that means my new interval, remember how I cut them in half earlier when it was x over 2? In this case, it's 2 theta. So my new interval is 0 times 2 is 2, but 360 times 2 is 720. That means I'm going around the unit circle 2 full times. 2 circles. And that's where I'm going to give all of my answers. So here's where it gets a little bit tricky, is I'm looking at the unit circle, where is the y value? Radical 3 over 2. So my first answer is in quadrant 1, and that's a 60-degree reference angle, and we're in theta, or we're in degrees here, so 2 theta equals, remember it's whatever is here, is what you are finding the angles for. So 2 theta equals, the first place where the y value in the unit circle equals radical 3 over 2 is 60 degrees. In quadrant 2, the answer is 120 degrees. But I have to go around the circle another time because I'm supposed to give my answers on 0 to 720, not 0 to 360. So I have to go around the circle a second time. So how to do that is to add 360 degrees to each of your answers, because they just have to go around the circle one more time. So 60 plus 360 is, what is that, 420. And 120 plus 360 is 480. So those are my 4 answers where 2 theta equals radical 3 over 2 for sine. And now what I have to do is just divide everything by 2 so that I can get theta by itself. Divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. That means that theta equals 30 degrees, 60 degrees, 210 degrees, and 240 degrees. And those are my answers for this problem. Okay, I know that was a little bit confusing. Let me zoom out and kind of recap, because I get that this is a little bit weird. What we're doing here is we solved, and we got the sine of this thing by itself. At this point, I looked at the unit circle, where is the y value equal to 1/2, but I stopped. I had to cut my interval in half due to the fact that this is x over 2. That means I'm only looking on the unit circle at 0 to pi. I did the same thing over here, and I talked about why there's only one answer here on 0 to pi, because that's the only place where the cosine is positive on 0 to pi. When I got down to this one, I didn't have to worry about doing anything to the interval, because once I was looking at the unit circle for this equation and this equation, these are just regular x's. So I did not have to manipulate my interval whatsoever. This last one was different. Once I was looking at my unit circle for answers for this isn't theta over 2, it's actually 2 theta. That meant that I had to multiply this interval by 2, which means my interval is 0 to 720. So I have to find all the answers here that go around the circle 2 times. The sine is radical 3 over 2 in 2 places around the circle 1 time. But if I have to go around the circle again, I have to add 360 to both of those numbers, which is how I got this one and this one. And just remember that that was 2 theta, so to get theta by itself, I had to divide everything in half. We will do the rest of the 3 problems tomorrow in class, and I'll be able to answer whatever questions you have, but at least now you have an idea of how we are going to modify our intervals based on the question asked, okay? And just remember, we're going back to unit circle stuff still. This isn't new info. This is a new way of asking you the same question we've been doing all semester long, okay? Bring those questions to class. Thanks for watching. Have a good night, you guys. This is your last video of the chapter. Hooray.